If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in power system series. So today again we will be solving 5 questions starting from question number 191 to up to 195. Okay, then let's try to solve these questions. Okay, in question number 191, a 3-bus network is shown in the figure below, indicating the per unit impedance of each element. So these are impedance in ohms. The bus admittance matrix Y bus of the network. So you can easily find it out, Y bus formation. So if you want to find capital Y11, what was this one? Capital Y11 is the element in Y bus. So this is small y11 plus small y12 plus small y13. So it is 1 by j.1 plus 1 by j.2, and this is 0. 1 by this, there is no branch between 1 and 3, so it is infinite, that is y is 0. So if you add this one, it will be minus 15 j into, that is j10 j5, so minus j5 minus j10 minus j15, so minus 15 j. Similarly, you can now calculate all other branches. Y12 is equal to minus of y12, that is minus of 1 by j.2, so it is minus minus plus 5j. So from here you can see it will be minus 15 plus 5, that is your option B is automatically it is coming. So it is option B automatically, you can see minus 15j and then minus 5j. Two terms we have calculated, there are other terms, this is 0, 1 3 is not there. So you can see by seeing only first row you can see it is minus 15 5. So similarly you can calculate other branch, no need, from here only you can, it is visible. So that is option B. Now if you come to 192, the bus admittance matrix of a 3-line system is this. If each transmission line between two buses is represented by equivalent pi network, then the magnitude of the shunt susceptance of the line connecting to 1 and 2. 3 bus, 3 line. So let me draw these buses. Suppose these are 1, 2, 3 buses. So this is one line, this is another, all are connected to each other, that's why no 0 is there. Suppose this is bus 1, this is they are asking for bus 1 and 2. Suppose this is 2 and this is 3. So shunt susceptance connecting in bus 1 and 2. Okay. So if you see this line, this bus, this line 1, 2. So there will be shunt susceptance of that line because of pi network. So this is y12, half of y12, and this half, because it is pi network we give half of, so this is also grounded y12. For this line y13 there will be another one. So now you can see actually the shunt susceptance that is connected in bus 1 is this plus this, and here also due to this line there also one shunt susceptance will come, that is y13 by 2. It is the pi network, you can recall your pi network, two capacitors y by 2 and z. So similarly here it will be again one more here, this will come, that is y2 3 by 2. Here also one capacitor shunt will come, that is 2 3 by. So you need this one. So what is the total shunt susceptance connected in one bus? If you add these two, then you will get minus 13. If it is 0, then nothing is connected. So 15 minus 13, that is 2j. So that means your capital or small y11 is equal to 2j. How I have calculated? Minus 13 plus 10 plus 5. If you add all this, then it becomes this much. So this much is there extra in bus 1. And what is this one? This is shunt susceptance connecting bus 1 and 2. That is, they are asking y12. They are asked you to find y12. Sorry, not this summation of these two. They are asking just y12. So this is 2j, and this is equal to how much? This plus this. So that means y12 by 2 plus y13 by 2 is equal to 2. J I am leaving it. You can easily understand. So yn3 is equal to 4. Similarly, you can go for rest of the things. For suppose bus 1, bus 3. So y13 plus y23 is equal to, for bus 3 if you add again this sum of all 3 is again 2. Minus 13 plus 10 plus 5, again it is 2. So it will be 4. So equation 1, equation 2. One more equation we'll have in bus 2, that is 1 2 plus 1 2 3. This by 2 is equal to this one. Second bus if you again add 10 10 20 minus 18 is 2. So divide by 2 equal to 2, so that will be 4. Now if you, because they are 4 4, you can easily say that is 2 2 2, or you can easily simplify and calculate. You can easily calculate 3 unknown, 3 equation. If you solve, you will find y12 is equal to 2, or it is easily visible also because all are 4 4. So best will be if you give 2 to them, This one also 2, this one 2. Then either all equations are satisfied? Yes, all equations are satisfied, giving 2, 2. So obviously 2, 2, 2 is an answer. If you can see it directly, then it's okay. Otherwise, you simplify. You solve these three. Next, if you come to question number 193, in the following network, the voltage magnitudes of all buses are equal. Okay, the voltage angles are very small and the line resistance are negligible. All the line reactance are equal to J1. The voltage angles in radian at bus 2, 3. This is a common question for 193 and 194. Okay. Now, if you see this one, because there is no loss, now this 0.1 power is coming here. So forget about this one. In power, you can apply this current division law and summation of currents, that you can do. Superposition, that means 1 by 1. One generator you take, how much current is flowing, and then this one, because there is no resistance, no drops will be there. So you can easily consider. So if you see here, what is the total impedance here? J1. If you see here, this is 2J. So obviously the power will flow through the smallest impedance path. So this power, so 0.1 will come from this side. It is clear. So no current will flow through this side. So all 0.1, because the demand is 0.2, so 0.1. And how much is more required for demand? Total is 2, you are giving 1, that means 1 is more required, that is 0.1. So it will come from slack bus. So this is delivering 0.1. So this is also delivering 0.1, this is also delivering 0.1. And this reference slack bus angle, we always consider it is 0 degree, something 0. So this angle will also be something 0. And all are 1. So this is also 1 angle 0, 1 angle 0. They have given all buses are equal to 1 per unit. So what will be this angle? This angle will be slightly smaller than this, so that the power will come. And same power it is getting. You can see it is 0.1, 0.1. That's why I have given 0 here. Why I have given 0 here? Because if you take 0, then there must be angle. Okay, let me do it. Don't think that I have given here 0. You just do it here. How much angle it should be? How much power you want to send from bus 1 to bus 3? You want to send 0.1 power. So power is equal to, because the no loss is there, V1, V2, because all angles voltage magnitudes are 1, divided by X is 1, and then sin delta. So what will be your delta? If you do your delta, then it is 0.1 radian. Sin delta equal to 0.1. If you take sin 0.1, then it will be 0.1 radian. Okay. So this angle is in radian they are asking. So this angle you got, that is 0.1, one angle 0.1. Now what should be this angle? Because you want to send same power, so the angle difference should be same. So the angle difference should be here 0.2, so it should be 0. Also there should be no power flowing through this branch, because both are feeding to this side, so power is coming from this. So this angle should be obviously same, that's why it is 0. So now you can see what are the angles. So they are asking theta 2 and theta 3. So theta 2 is this one, that is 0, and theta 3 is minus 0.1, 0 minus 0.1, that is option B. This angle should be minus 0.1, not 0.1. Then only power will flow from this and this. Now if you see 194, if the base impedance and the line to line voltages, base voltages are given, this, then real power. So impedance is given, base impedance, so that is 100 ohm. And VLL base, what is the formula for Z base? It is B square by power, B square by P. That was the formula. Now if you can recall that formula, what power we have taken that side? We have taken that power is a line to line voltage. You can take this one as VL per phase, then your power will be also per phase. So total power if you want to take, then it will be 3 into you have to take, then power base will be multiplied by 3. Ultimately if it is line, then total power you can take, because it is VL by root 3. So it is what Vp will be VL by, if you take solar, that is Vp square by 3P. That means you are considering P per phase. So no need, you directly you can put 100. So it is 100 square, K square will give you mega divided by X. So answer will be in mega, and that is equal to 100 also. So X is equal to, that means 100 megawatt. So this is the base of power. X is nothing but power base. Power base is 100 megawatt. So power is how much it was flowing. Now they are asking the power delivered by the generator connected to the slack bus. So how much slack bus is giving? Slack bus is giving 0.1 per unit. So in megawatt it is supplying 0.1 into 100, that is 10 megawatt it is supplying. So that's why this is the answer. Okay, so what it is given? Single phase load supplied by a single phase voltage source. If a current is flowing through the load, from the load to the source, so this power they have given. Generally what we take, power is entering, but here giving from the load to the source, it is 10 at an angle of minus 150. And if the voltage across the voltage at the load terminals here, the voltage here, it is 100 at an angle of 60. Then, so what is generally load convention? We generally take the power current is entering to here, then we say it is Vp plus Jq, which is equal to Vi star, total power entering to this bus. If I take this current as they have given, then it is the power delivering by the source. So V into this star will be the how much power is going from that side. Okay, whatever. So if you take that also, it will be okay. If you go by load convention also, that will be okay. So if I go by load convention, how much power is coming? So V and I, then this I is equal to minus of this one. Why I am saying minus of this one? Because generally load convention is current is entering. So I am giving minus because in load convention generally we take current is entering. So that's why I am going with that load convention. So if you solve this one, it will be 100 at an angle of 150. Then if you multiply, it will be 1000 at an angle of these angles will be added 210. Now you can take sine cos. Finally what answer you will get is 866 plus 500 I. So both are positive, that means yes, they are absorbing, because loads is always, what is the format? If I write P plus JQ in terms of load, that means yes, the load is absorbing P, load is absorbing Q. So both things are absorbed because both are coming positive. If you don't take this one, then you will get minus. That means what it is delivering is negative power it is delivering, that means ultimately it is absorbing. So it's better you go by load convention only. That's good, no confusion will be there. So it is absorbing both real and reactive power. That is your option B. If you like the video, then press the like button and please give your valuable comments in the comment section.